Hi, and welcome to Aspire Test Prep's video on using the discriminant to find the number of solutions. Aspire Test Prep offers online SAT and ACT tutoring for students and test prep classes for high schools. You can get more information at www.aspiretestprep.com or at the phone number on the screen. Now, this worksheet, as are all of our worksheets, is available on our website under Prep for free. And what you can do is you can try the worksheet, go ahead, see how well you do, check your answers on the answer key, and if you really need help, use this video for step-by-step guidelines on how to do some of the problems. So starting with number 1, we have the discriminant used to find the number of solutions in this problem. How many ordered pairs satisfy the system of equations above? Now, when we're talking about satisfying a system of equations, we're talking about the intersection between the two functions that they're giving us. So this function right here, because it's got an x and a y, and neither one is squared, we know that this is basically a line. This one here, it's got two x's that have to be FOILed out, that have to be multiplied together. So we already know we'll have an x squared. So this is going to be a parabola. Now, when we go ahead and try to figure out where do this line and this parabola intersect, we need to ponder some different scenarios. For instance, we could have the line right here and the parabola right here. In other words, they can never hit. We can go ahead and have the line and the parabola hit at exactly one location, like that, or the line or the parabola could be in a different spot, creating a situation where they hit twice. So if they don't hit at all, that's 0 solutions. If they hit once, that's 1 solution, and if they hit twice, that's 2 solutions. So what we need to do is basically figure out how many times these hit each other. Now, where functions intersect, points of intersection, those are points where the x and y values are equal to one another. So if I have two functions and I want to know where they intersect, I have to imagine that the point where they intersect is going to be a point where they have the same x and y values. That's why they intersect, right? Because they're passing through the same points. So what we want to do on most of these is go ahead and get them in the format of, y equals something for one of the functions and y equals something else for one of the other functions, and take those two things and set them equal to one another. And that's what we're going to do here. If you'll notice, one of these functions is already in the format of y equals. So that one's kind of where we want it to be. This one here is in the format of x equals something. So we need to kind of move things around to get it to look the way we want it to look. So we can go ahead and just perform some operations on that one. Right now we've got x equals 3 parentheses y plus 8, so we can distribute that, 3y plus 24. What we're trying to do right now is get y by itself. So we can take away 24 from both sides. X minus 24 equals 3y. Then we can divide both sides by 3. And y equals x over 3 minus 24 over 3, which, by the way, is 8. Make that a little neater. Okay, so now what we have is, we have y equals x over 3 minus 8 for one of the functions, and y equals all of this for the other function. So the key is to set those two things equal to one another. So we can say x over 3 minus 8 equals 2x plus 5, 4x plus 2. Now we can just start going through our simplification steps, FOIL out the right-hand side. So first times first is 2x times 4x, so 8x squared. Outer times outer, 2x times 2, so that's 4x. Inner times inner, 5 times 4x, so that's 20x. Last times last, 5 times 2, and that's 10. So we have x over 3 minus 8 equals all that stuff. And Now to get rid of that 3 in the denominator, we can multiply both sides of the equation by 3. That'll give us x minus 24 equals, and actually before that what we really should have done is combine this into 24x, because 20x and 4x is 24x. But now we're multiplying everything by 3, so we'll have 24x squared plus 72x plus 30. Now this, of course, is a quadratic. We've got x's and we've got x squareds. And those are the ingredients of a quadratic. Now when we say the word quadratic, we mean a lot of things. We mean the quadratic formula or factoring. We mean it's a parabola. But perhaps one of the first things you want to think about when you have a quadratic is you need to get one side of the equation equal to 0. So if we take away x from both sides, and if we add 24 to both sides, we get one side of the equation equal to 0, and the other side looks like a regular quadratic in the format of ax squared plus bx plus c. Like that. A being 24, b being 71, and c being 54. So now, if we were to solve this, that's our a, that's our b, that's our c, we can plug this into the quadratic formula, but the quadratic formula, first of all, looks something like this. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And you have to have that memorized because on the redesigned SAT, there's going to be lots of situations where you need to be able to use that formula. But let's just imagine we threw in some random numbers and the final answer came out like this. Let's say 3 plus or minus square root of 4 all over, let's say, 2. So here, at the next step, it would be 3 plus 2 over 2 and 3 minus 2 over 2. So if it looked like this, we'd have 2 answers because we'd have the plus or minus the square root of 4. Let's say we did the quadratic and it came out looking like this. 3 plus or minus square root of 0 over 2. Well, now square root of 0 is 0, so we have 3 plus or minus 0 all over 2. So in other words, the thing that we're adding or subtracting doesn't even really exist. It's 0. Therefore, there will only be one answer. We're not adding and subtracting something like we were the first time. Finally, what if we had 3 plus or minus the square root of negative 4 over 2? Here, we have square root of a negative, which is forbidden in math. It's not allowed. So, this is no solution. Or, we can say there's 0 answers. So what is it that we're saying here? We're saying that if you have a positive number, 0, or a negative number under the radical in the quadratic formula for the b squared minus 4ac, you're going to have 2, 1, or 0 solutions. So this is what this entire lesson is about. It's the idea of using the discriminant in order to find the number of solutions. So the discriminant is the b squared minus 4ac part of the quadratic formula. If we go ahead and arrange that part, we have b is 71, so 71 squared minus 4 times 24 times 54. All we need to do is determine whether this answer is positive or negative. So 71 squared is 5,041 minus 4 times 24 times 54. So minus 5184. And so obviously we're subtracting a bigger number from a smaller number. We don't even need to know what the exact answer is, but the point is we tested out the discriminant. This is the discriminant right here of the quadratic formula. We found out it was negative, and that means we have 0 solutions. So how many ordered pairs satisfy this system of equations? 0. If we were graphing it, we would see a parabola and a line that don't hit each other at all. So that's what's going on there. What I'm doing now is going to Aspire Test Prep, and I know it's not showing up on the screen. I'm clicking on Prep for Free, and I'm clicking on this lesson, which is finding the discriminant. It's the discriminant, and I'm clicking on the answers, and I'm verifying whether I had the right answer, because that obviously will be important to this lesson. Okay, so we ended up with a negative number for the discriminant. Great. Now coming over to number 2, how many ordered pairs satisfy the system of equations above? Like I said, at the point where lines intersect, we have their x's and their y's equal. So if we can get both of them in the format of y equals something, then we can set those two things equal to one another. So taking away 4 from both sides, dividing both sides by 2, we have y equals x over 2 minus 2, and y equals 2x squared plus 8x plus 5. So if we want to make these lines intersect or find out where they intersect, we need to take both of those expressions and set them equal to one another. Now we're simplifying. We're multiplying both sides by 2. Now, because it's a quadratic, our instinct needs to be to get one side of the equation equal to 0. So we're taking away x and adding 4 to both sides. So we have 0 equals 4x squared plus 15x plus 14. Now, we could find answers for this if we were asked what the answers were, but we're not. We're being asked how many answers there are. And that comes from whether the discriminant is positive, negative, or 0. So here a equals 4, b equals 15, c equals 14. b squared, 15 squared, minus 4ac, and 15 squared is 225, and 4 times 4 times 14 is 224. So we know now this is a positive number 1, and a positive discriminant means that there are 2 real solutions. Okay, so that was number 2, and now we're going over to number 3. Number 3 says, in the equation above, b is a constant. If the equation has no real solutions, which of the following could be the value of b? Okay, so no real solutions is the key here. As we've been saying, if there are no real solutions, that means that the discriminant was a negative number. So even though this has an extra variable that we're not used to, it's still a quadratic because it's got x squared and x. So we can arrange it like a quadratic, in other words, get one side equal to 0, by taking away b from both sides, and we'll get 0 equals 3x squared minus 5x minus b. And in order to get there, we took away b from both sides. Now, the discriminant, the b squared minus 4ac, is going to be negative 5 squared minus 4 times 3 times negative b. Simplifying that a little, we have 25 minus, or actually plus, 12b, because we've got 2 negative signs here, and 2 negative signs make a positive. Now what we said is that there are no real solutions, so that means that the discriminant has to be a negative number. So we can take that and say that it's less than 0, it's negative, and simply solve that inequality. Taking away 25 from both sides, we have 12b less than negative 25. Dividing by 12, b is less than 25 over 12, which is 2.833, negative 2.083 repeated. So now, which of these answers could be B? On a number line, it has to be smaller than negative 2.083. So 0, negative 1, negative 2. And our number is somewhere around here. And negative 3. And okay, so our number is somewhere around there. And our inequality says that we are going to be at that number. And we're going to go in the smaller direction. In other words, negative 3 fits within that solution set. So negative 3 is our answer for number 3. Okay, and going over now to question number 4. 2x squared minus 7x equals negative a. So it's a quadratic. We need to go ahead and get one side equal to 0. 2x squared minus 7x plus a equals 0. So we added a to both sides in order to get 0 on one side of the equation. Here we're finding out that the equation has one real solution. One real solution means the discriminant is 0. So let's get the discriminant and then we'll set it equal to 0. So the discriminant is b squared, negative 7 squared minus 4ac. So the thing in the c spot is the letter a. And that simplifies to 49 minus 8a. And the discriminant has one solution, so this is equal to 0. Now we can solve that out, add 8a to both sides, divide by 8, and a equals 49 over 8. Now this is different than the question before where we had an inequality. Here we know the exact answer for b, because in order for the discriminant to equal 0, b, or a, the letter a, has to be 49 over 8. Going over to number 5 now. The equation has two real solutions. Two real solutions means that the discriminant has to be a positive number. So let's go ahead and get it into a quadratic form by adding p to both sides. We have negative 3x squared minus 5x plus p equals 0. So that means our a is negative 3, our b is negative 5, and our c is p. b squared minus 4ac is negative 5 squared minus 4, negative 3, and p. And that has to be greater than 0. Simplifying a little, negative 5 squared is 25. Here we have two negative signs and a positive, so we know this entire thing will be positive, plus 12p greater than 0. Now to solve, we can take away 25 from both sides, and we have 12p greater than negative 25. By the way, with inequalities, if you multiply or divide by a negative, you flip the inequality the opposite way, but here we haven't done that. We're dividing by a positive number. And p equals negative 24, or is greater than negative 25 over 12, which is, once again, 2.83. So p is greater than negative 2.083 repeated. And if p is greater than that on a number line, we have negative 3, negative 2, negative 1, 0, 1, and let's say 2. And our number needs, okay, so negative 2.083 would be around here. Our solution is saying that we want numbers that are greater than that. So which one could not be the value of p? This question is asking us which one is not in the solution set, and the number negative 3 is right there. So that's our last question. We hope that this helped you to understand a little bit better how to use the discriminant to find the number of solutions. This is a concept that occurs frequently on the redesigned SAT. If you have any questions, you can reach out to us at tutoring@aspiretestprep.com or go to our website, www.aspiretestprep.com. If you feel like you're getting a lot out of these lessons, you can thank us by recommending our online tutoring to your friends and family, and also by asking your school to go ahead and request an SAT or ACT class from Aspire Test Prep. Thanks very much.